Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have studied few numericals which are based on Gibbs free energy change, and now we are going to do the third type of it based on some few different kind of numericals. So let us do it. Hello friends, as on your screen there is a question which is based on Gibbs free energy change, and now we are going to study. इसमें बताया मैंने. Hello friends, now we are going to do the third numerical which is based on Gibbs free energy change. So let us do the observation of the question and let us see what are the requirements of the given question. So the question says that we have to write the cell reaction and calculate the EMF of the cell at 25 degrees Celsius. The cell formula that has been given as chromium, which has been converted into chromium 3 plus, in which a salt bridge has been used, and CO2 plus ions is now being converted into CO, that is cobalt. So the E0 of CO, that is the standard potential of the electrode, is given as minus 0.280 volt, while that of the standard potential electrode of chromium is given as minus 0.74 volt. And from that case we have to calculate also what will be the delta G for the reaction. So let us first of all calculate first that which one is anode and which one is cathode. So the given cell is chromium that has been converted into Cr3 plus, in which CO2 plus is being converted into CO. So this is the cell formula that they have given to us. So according to IUPAC notification or according to IUPAC convention of a cell formula, we know that the electrode which is present on the left hand side, or we represent anode on the left hand side of a cell formula. So in this case, this is the cell formula in which chromium is the substance or is a electrode which is placed at extreme left of the cell formula. So therefore this chromium is nothing but an anode. So therefore in this case the anode is chromium, while that of the one which is present on the extreme right of the cell formula is said to be a cathode. So therefore the cathode in this case will be the cobalt. So this is how we have calculated first that which one is anode and which one is cathode. So now based on this we could easily write that what could be the cell reaction based on this cell formula. So the first thing that we are going to do is we are going to write about the cell formula. The cell formula has been given, that is Cr, which is present in solid form, which has been converted into Cr3 plus. Again the concentration of this is 0.0065 molar. A salt bridge has been used, and again we are in which CO2 plus, that is it has been having a concentration of 0.012 molar, which has been deposited in the form of CO because this is a cathode section. So this is the overall cell formula that we have represented, but the anode should always have a negative charge while that of cathode should always have a positive charge. So this, since chromium is acting as an anode, this will show oxidation. So this chromium will lose 3 electrons so as to form Cr3 plus, while this CO2 plus will accept 2 electrons to form CO, which is acting as a cathode. So let us write the cell reaction of it. So the cell reaction can be represented as, at anode oxidation takes place. So therefore in this case the chromium which has been converted into Cr3 plus, it means this anode section is undergoing oxidation. So therefore Cr, that is chromium, is converted into Cr3 plus by exhibiting 3 electrons. We could also write the state, physical state of the matter in this case. So let's talk about the another one, that is at cathode. At cathode, as you know, reduction takes place, and in this case the CO2 plus is been converted into CO. That means we could write this as CO2 plus will accept 2 electron so as to form a solid cobalt. And now we could take the overall reaction, but before taking the overall reaction we should observe that are the number of electrons same during oxidation and during reduction. So they are not same, because the one is exhibiting 3 electrons while the one is intaking 2 electrons. So they are not same, so we have to make it same by once, since we have learned this in redox reaction in 11th standard also. So suppose if I want to balance this 2 electrons, so the thing that I should do is I should multiply this equation by 2, the whole equation by 2, and I have to multiply this equation, that is this half cell reaction, by 3. So what is the overall reaction that I could get? I could get the overall reaction as, I could write it on another page. I could get it as, at anode in which oxidation takes place, since I have multiplied this equation by 2, so therefore the overall equation will also be multiplied by 2. So therefore I could get 2 times of chromium, that is giving us 2 moles of Cr3 plus 6 moles of electron. While in other case, that is at cathode, what I am going to do is I am multiplying it by 3. So therefore at cathode, where reduction takes place, in this case 3 times of CO2 plus will accept 6 times of electrons so as to give 3 times of CO in a solid form. So now we could take the overall cell reaction. See, this is a different kind of numerical that we have did now. Okay, so it will be very much beneficial for you to solve this kind of numericals. So please pay good attention in this thing so that it could help you to gain much more and better marks. So I could take the net cell reaction very easily now. In this case, I could see that this 6 electrons that is present on the right hand side, this will cancel out the 6 electron which is present on the left hand side. So the overall reaction that is left with us is 2 times chromium plus 3 times of CO2 plus, that will exhibit 2 times of chromium 3 plus 3 times of cobalt which is present in solid. We should also represent the physical state, so in this case we could write in this way. So this is the overall net cell reaction that we have got, but eventually we could also determine that what would be the number of electrons that had participated in the half cell reaction. So I could see that the overall the number of electrons that has been participated in the half cell reaction is 6. So therefore here itself I could write that the value of n is 6, and this will be very much beneficial for us to evaluate the next kind of data or next kind of requirement that has been asked in the given question. So now the thing that I have to do is we have to calculate what would be the E0 cell. So let us see. But we know that E0 cell is nothing but E0 of cathode minus E0 of anode. So in this case, which one would be the cathode and which one would be the anode? It's very simple to determine. See, according to the cell formula, we have written that the anode is the chromium one while the cathode is the cobalt one. So I could write it in a very easy form that the cathode is nothing but the cobalt while that of the anode is nothing but the chromium. So based on this thing, we could easily calculate what would be the E naught cell. So in this case, as in the given question that they have mentioned, that the E naught cell, or I could say that the E naught of cobalt, that is the standard potential of electrode of cobalt, in this case is given as minus 0.280 volt. So therefore minus 0.280 volt minus of, again for chromium they have mentioned that it is minus 0.74 volt. So I could write it as minus 0.74 volt. So in this case, minus 0.280 volt, minus into minus will be plus. So therefore it will give us 0 plus 0.74. And if I calculate this thing, then I could get 0.46 volt. So this is how we have calculated what would be the E naught cell. And now based on this, we have to calculate that what would be the delta G value. But since we have to calculate the delta G value, but for delta G we should know what would be the E cell, or what would be the cell potential of a particular cell. So how can we calculate? Based on this formula we could calculate, because we know that the relation between E cell and E naught cell is E cell is equals to E naught cell minus 0.0592 divided by n log to the base 10 of concentration of product divided by concentration of reactant. And this formula is for the temperature when it is at 25 degrees Celsius. So in this case, the E naught cell that we have calculated, it very easily, that recently we have calculated, it was 0.46 volt. So the value of n that we have initially calculated also, it was found to be 6. So therefore 0.0592 divided by 6 into log of concentration of product divided by concentration of reactant. So in this case, the concentration of product would be, as I will show you now, that we have did that 2 moles of Cr3 plus 3 moles of cobalt. So I could write this as we know that the law of mass action, we could represent this thing as concentration of Cr3 plus raised to 2, because the number of moles is acquired by the chromium 3 plus is 2, multiply by the another product which is cobalt, which has a stoichiometry of 3 moles, divided by the reactant. In this case the reactant is chromium, which is present in solid form and which has a stoichiometry of 2, while that of the cobalt 2 plus has a stoichiometry of 3. So I could write it in this way. So the thing that we should know is that the cobalt and the chromium, which are present in a solid form, will have a molecularity of unity. Means the value of the concentration of cobalt and the concentration of chromium will be 1 when they are present in a solid form, or they are present in a solid state. So we could avoid these two things by taking the value as 1. So the thing that is left with us is 0.46 divided by 0.0592 divided by 6 log to the base 10 of the concentration of chromium 3 plus. I could write it so as there would be no kind of confusion while writing this thing. So 3 plus raised to 2 divided by the concentration of reactant, that is CO2 plus raised to 3. Now I could easily substitute the value and we could evaluate what would be the value of E cell very much easily. So therefore we could get 0.46 minus 0.0592 divided by 6 log to the base 10 of, for concentration of Cr3 plus we have a value that they have been provided in the question itself, which is For Cr3 plus, they have provided the value as the concentration is 0.0065 molar, while that of the CO2 plus is 0.012 molar. So I could substitute the value of Cr3 plus in this case as 0.0065 raised to 2 divided by 0.012 raised to 3. And now let's see what would be the value that we could get. So in this case, I would write in this way, that is E cell is equals to 0.46 minus 0.0592 divided by 6 log to the base 10 of, let me calculate what would be the square of 0.065. It is found to be 4.225 into 10 raised to minus 5, while that of the cube of 0.012 will be 1.728 into 10 raised to minus 6. So this can be done very easily, and now we could calculate, that is 0.46 minus 0.0592 divided by 6 into log of this thing would be, we have got the value of this factor as 1.388. So now we could calculate it in a very easy form. So let us see what is the final answer that we have got for E cell. So we have got the value as 0.446 volt. This is the value of E cell that we have calculated by using this formula. But this is not the end. We have to calculate the value of delta G also. So let us see what is the relation between the delta G, that is Gibbs free energy change, and the E cell. We know that the delta G has a formula of minus NF of E naught cell if delta G naught is been asked, and for delta G it would be minus NF of E cell. So now in this case we could calculate the both of things, because we know what is the value of E naught cell as well as we know that what is the value of E cell in this case. So the requirement is been asked for delta G itself, so we could find for delta G here in this case. So we could get the value of N, which was found to be 6, into the value of F, that is Faraday constant. We know it very well, that is it is 96500 coulombs per mole. And talking about the E cell, that we have recently got the value of E cell as, in this case we have got the value of 0.446 volt. So this is 0.446 volt, and let us see what is the overall answer that we could get. So we have got a value of minus 258234. This will be in joules. So because this is Gibbs free energy change, so therefore this will be in joules. So we could calculate in kilojoules also. So the thing is, when we mention this thing in kilojoules, we'll get a value of minus 258.234 kilojoules. So this is how we have calculated the value of delta G by the help of the value of E cell, by the help of the value of E naught cell, and we have also mentioned that what would be the anode and what would be the cathode one. We have also written what would be the overall net cell reaction. So that was a very huge numerical. So I hope you have got this video and you have got excited to solve this kind of numerical in your exam or in your future. So thank you friends for watching this video. I hope you have liked this video and you have understood this concept very clearly. So share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.